Hello, everyone. Welcome to the third podcast from day 40 on ecosystems. In this one, we're going to talk about how inefficient it is to transfer energy between the trophic structures. Let's go ahead and get started. Okay, let's go ahead and get started with objective 3 here. And I want to begin by drawing a picture very similar to the one that you have in your book on figure 5510. And in this figure, we see a leaf. We'll draw a leaf here as best as I can. And on this leaf, there is a caterpillar crawling on it and eating it. You know, the caterpillar here is an herbivore. It is a primary consumer, so it eats the primary producers. And we can calculate about how much energy this caterpillar obtains from this plant. And your book uses this number, and so we'll use it too. It's a good enough number. In total, about 200 joules of energy this caterpillar gets from this plant. Now, not all of this is going to be used by the caterpillar for its own growth and development. As we said earlier, there's a cost of doing business. In order to survive, it's got to expend some of that energy. And we know some of that energy is going to be lost due to its own respiration. In order to use some of that carbon that it's obtaining from this leaf here, it costs some energy. And so it's going to cost, if you calculate it, 67 joules. That still leaves us 133 joules. But we know that a large part is actually just lost as waste through feces. And we know this is about 100 joules that is lost here. So what's left now is, out of all of this, there's only about 33 joules left for its own growth. This amount of energy here that is used to go towards its own growth, its own biomass, we call this secondary production. The amount of that energy that goes towards the organism's growth. So it's subtracting what's lost through feces and what's lost through cellular respiration. And this is all you need to know about this particular concept. There are some equations your book talks about, but you don't need to know that. If you know this much here, you're in good shape. And we should kind of also, a big take-home point here, let's write that up here too. And that is, throughout this process, we're going to learn that production efficiency is very low. In fact, we really think in most systems, it's only about 10% efficient, meaning you lose about 90% of all that energy that comes into you. This is a little bit better than 10%. The 10% is an estimate. Now let's think about this beyond just one particular interaction, this herbivore interaction with the plant. Let's think about these interactions and the efficiency of the energy upon the whole trophic structure, along the whole food chain or food web. So that's thinking about the efficiency within the trophic structure. Let's define trophic efficiency. And this is the percentage of production transferred from one trophic level to the next trophic level. And figure 5512 does a pretty good job explaining this concept, and we're going to redraw that here. 5511. And so let's begin at our primary producers level. So primary producers. they obtain about 10,000 joules. And what's amazing is that what's available to them is about 1 million from the sun. So 1 million joules from the sun. But they only get about 10,000 joules from that. Joules, I should have defined this earlier. Joules is just a unit of energy. Now as we move up the trophic level here, we can go to our primary consumers. As this energy is transferred to these primary consumers, we lose about 90%. And so we only have about 1,000 joules that it can actually use towards biomass. The rest, the other 9,000, is lost due to oxidative cellular respiration and through feces. Then as we move up, to our secondary consumers, there's only about 100 joules available for this secondary consumer to use towards biomass. Then as we move to our tertiary consumers, they only get about 10 joules from consuming this 100 joules of energy. There's only about 10 joules that they can use towards biomass. So to summarize, as you move up the trophic levels here, you lose about 90%. That loss of 90% of that energy that's consumed is lost due to cellular respiration, or feces. Cellular respiration, as we said before, that energy is consumed in it and it's lost as heat, and feces is just the waste product. So it's a pretty inefficient process as you move up this level here. The cost of doing business is quite high. So let's close this with a question here, and that is, what would happen if, let's say we're a tertiary consumer or a quaternary consumer, and we eat a lot of a meaty diet, eat a lot of tertiary consumers, and very little primary producers, that is very little plants. If we converted to a vegetarian lifestyle and primarily fed at this primary producer level, how would that affect everything else? Would we gain more energy? Would this allow more energy available for other trophic structures? What would be the overall impact of that? All right, that's it for this podcast. If you have any questions, please let us know. We'll see you in class. Bye.